So now we look at the solutions of assignment number 3. And first of all, we look at the solution to question number 1. So in question number 1, we are given with a decimal number and we have to convert it into binary. The number given is 0.25 and we have to convert it into binary. As the number is floating point, so we will use this procedure. So first of all, we will multiply the number with 2. Because we are converting it into binary, so we will multiply it 2. 0.25 into 2 is equal to 0.5. So in this case, we can see that the integer part is 0 and the fractional part is 0.5. So is the fractional part is equal to 0? No, it is not 0. So now 0.5 will come here and we will multiply 0.5 with 2. So 0.5 into 2 is equal to 1.0. So integer part is equal to 1 and fractional part is equal to 0. Now, yes, the fractional part is equal to 0. So we will stop the process. And we will calculate the answer by going from top to bottom of the integer part. So we can write the answer as the decimal point will maintain its position. So point will stay here and we can write the answer as point. And first we write 0, 0 comes here and then we write 1. So 1 comes here. So now we can say that the number 0.25 in decimal is equal to 0.01 in binary. Next we move to question number 2 solution. So in this question we have to convert our decimal number into octal. So this is the decimal number 0.16. So as the number is 0.16 and we have to convert it into octal, so we will multiply the number by 8. So first of all, we have the number 0.16 and we will multiply it by 8 and we get the answer 1.28. So now the integer part is 1 and fractional part is 0.28. So is the fractional part is equal to 0? No. 0.28 comes here and again we multiply it with 8. And we get the answer 2.24. So the integer part is 2 and fractional part is 0.24. Again not 0, so 0.24 will come here and we will multiply again with 8. And we get the answer 1.92. So integer part is 1 and fractional part is 0.92. Again not 0, so 0.92 will come here and we will multiply it with 8. So it is equal to 7.36. So integer part is equal to 7 and fractional part is equal to 0.36. Again not 0, so we will multiply 0.36 into 8 and the answer is 2.88. So integer part is equal to 2 and fractional part is equal to 0.88. So now we can see that the process is not ending and fractional part is once again not 0. So we will stop the procedure when we will do the steps 5 times. Okay. Otherwise it's a never ending procedure and it will keep on going on. So we will stop it and we will calculate the answer by going from top till bottom in this direction. Okay. So now we can say that the answer is decimal point will maintain its position 0.12172 in octal. So this is how we can solve question number 2. Next we move to question number 3 solution. And we can see that we are having a binary number and we have to convert it into decimal. The binary number is 1001.011. Now we will solve this whole number part using this procedure and this fractional number part using this procedure. Okay. So first of all, we look at the whole number 1001. Okay. So what we will do here is that we have to convert this binary into decimal. So we will multiply it with powers of 2 starting from 0 and increasing by 1 while moving away from the decimal point. So first of all, we have 1 here, so we will multiply it 2 raised to power 0. Then we have 0 here, so we will multiply it to 2 raised to power 1. And see, the powers are increasing. And then we have 0 here, so we will multiply it 2 raised to power 2. And then we have 1 here, so we will multiply it 2 raised to power 3. Okay. So, and then we will add them all together with each other. So now this becomes 8 and then 0, 0 and then 1. And when we will add it, it becomes 9. Okay, so the answer of the whole number is calculated. Now next we will calculate the answer of this fractional number, that is 0.011. So we write it here, and we know that we multiply it to negative powers of 2 while moving away from the decimal point. So first of all, we multiply 0 with 2 raised to power minus 1, and then 1 with 2 raised to power minus 2, and then 1 with 2 raised to power minus 3, and then we add them together. Okay, so this is equal to 0, and this is equal to 1 by 4, and this is equal to 1 divided by 8. So if we calculate the answer by adding these three values, it becomes 0.375. Now we will combine the answer of whole part and also the fractional part to calculate the final answer. So now we can see that 9 comes from here. So the answer is 9.375 comes from here. So this is how we can calculate the final answer, and we can say that the binary number 1001.011 in binary is equal to 9.375 in decimal. So now we move to the solution of question number 4. And in question number 4, we have to convert an octal number into decimal. The octal number is 751.52 in octal, and we have to convert it into decimal. So we will solve the whole number part using this procedure, and we will solve the fractional part using this procedure. Alright. So first of all, we solve the whole number part. So we have the number 751 here, and we will multiply each digit with powers of 8, starting while moving away from the decimal point. So first of all, we will multiply with 8 raised to power 0, then 8 raised to power 1 and 8 raised to power 2. So the first digit is 1, so we multiply it to 8 raised to power 0. And then the second digit is 5, so we multiply 5 with 8 raised to power 1. So the powers are increasing by 1 while moving away from the decimal point. So next we have the digit 7, so we multiply 7 with 8 raised to power 2. Okay. And then we will add them together to calculate the final answer. So here we have 448, and then here we have 40, and here we have 1. So after adding this and this and this, we get the final answer as 489. So this is the answer of the whole part. Okay. Next we have the fractional number 0.52. So here is the number 0.52 here, and we will multiply it with negative powers of 8 while moving away from the decimal point. So the first number is 5 while moving away. So we will multiply 5 with negative power of 8. So 8 raised to power minus 1. Next we will take the second digit 2, and we will multiply it to 8 raised to power negative 2. Okay. So here we get the fraction 5 by 8. And here we get the fraction 2 by 64. So we add them together and we get the final answer 0.65625. So now we got the answer of whole part and the fractional part. So we will combine them together to get the final answer by combining part 1 and part 2. So the final answer is 489 comes here, and then we have the decimal point, and then 65625 that comes here. So we combine the answer of part 1 and also part 2 to get this final answer. And we can say that the number 751.52 in octal is equal to 489 65625 in decimal. Next, we move to the solution of question number 5. So in question number 5, we have to convert a hexadecimal number into decimal. The number is 1a.be, and again we will solve this part using whole number procedure and this fractional part using this fractional number procedure. Okay. So first of all, we have the number 1a, and as we have to convert a hexadecimal number, so we will multiply the numbers with increasing powers of 16 while moving away from the decimal point. So a is multiplied with 16 raised to power 0 and 1 is multiplied with 16 raised to power 1. And we add them together and then we have 16 plus 10, and here we have the final answer 26. And here is the fractional number, that is point be. So we will multiply these numbers while moving away from the decimal point with negative powers of 16. So first of all, we multiply b with 16 raised to power minus 1, and then we multiply e with 16 raised to power minus 2. Okay, and then we add them together, and here we get the fraction 11 by 16, and here we get 14 by 256, and then we add them and then we get this value 0.7421875. Now again we will combine the answer of part 1 and also the answer of part 2, and we will get the final answer as 26.7421875 in decimal, which is the final answer. So again we have completed the solution, and thank you so much for your time. I hope you understand all of the solutions and I hope you have done the assignment yourself. Thank you.